So let's move on. Let's thank the speaker again, and then we can move on to the next talk. So the next talk will be given by Anna Maria. The title of her presentation is Experience of Implications of Roaming in Europe. And just to give you some background, Anna Maria is finishing up a PhD at University of Carlos Madrid under the prestigious European Marie Curie program, and she's moving to Imperial College London as a research associate in November. And her research interests are quite vast, ranging from TCP middle boxes to internet measurements and also other measurement platforms. And she's worked as an intern for Telefonica Research and Simula Metropolitan in Norway as well. So without much delay, let's hear from Maria.
Okay, thank you. Let's talk about our experience measuring roaming in Europe. First of all, I would like to thank Andra Luto, my co-author and also mentor in this project, for the amazing work. Thank you, Andra. She's in the audience. I will talk about motivations and what moved us to measure roaming in Europe, some little background, and the experimental setup, the actual measurement platform we invented to measure roaming in Europe, the measurements we made. We make three main contributions in terms of measurements. We study the roaming setup and performance, the traffic differentiation in roaming, so VoIP, and some content discrimination. And then the actual roaming results in these three fields. And since this is an experience paper, I will talk about our experience building this platform and how we created the dataset and process it. So, motivation. Roam.com is the initiative of the European Union to levy the extra charges while roaming in Europe. It means that finally, since June 2017, you can roam in Europe for free. It means you can use the data plan you have in your home country in the foreign country. If you're in Italy and you're traveling to Spain, you can do free call in the other country, in the entire Europe, including Norway, UK. But the motivation, why actually study roaming in Europe? So first of all, we would like to understand the roaming ecosystem after this new initiative of the European Union. Secondly, the questions we would like to answer are which technical solutions are actually being used, which is the roaming configuration that mobile network operators are using for roaming, and the third one, what are the implications of roaming for the end users? So what is the experience, the delay that the user can experience while roaming? But first, let's talk about a little bit about the background. So this is a standard network mobile infrastructure, and the standard is that you are at home, and then you are using your home infrastructure. While you're roaming, you can have three different configurations. So the first one is that you are using the mobile network operator can opt for home-routed roaming. It means that you are using the infrastructure. So while you are roaming, you are using the infrastructure that is at your home. You are using the P gateway at your home country. The other configuration is the local breakout. It means that you are using the infrastructure or the visited network, the one in the country where you are roaming. And the third one is the IPX hub breakout. It means that you are using a third-party infrastructure. Let's talk about the core of our paper, that is the experimental setup and the roaming Moro platform. So, first of all, why you think of this kind of measurements, you think how you can measure this, right? So you think that you can distribute mobile phones all around Europe and give to normal user, and this of course is difficult because how you can schedule the measurements, how you can synchronize them. So what we decided to do is build a measurement platform for roaming. This platform is developed in 6 different countries: Norway, Sweden, UK, Germany, Spain, and Italy. So we have 12 different roaming nodes, and we have a backend system composed by servers that collects all the measurements. And then we have 1 measurement server for each country we cover. And we have a mono roaming scheduler that is the core of our platform that synchronizes, schedule the measurements simultaneously. So we collect measurements for 3 months in end 2017 and beginning 2018. And we have 12 nodes in each of the countries we cover, 16 mobile network operators, and we collect more than 20,000 experiments. We measure 1 mobile network operator per time, all synchronized. And also, we measure the net-free visited network when possible. I will explain this later. For example, let's say we want to measure Vodafone Germany. So from Germany, we send manually, by standard mail, all the SIM cards to the other country. And what we do, this is our platform. So the scheduler, basically we put the home SIM card, in this case Vodafone Germany in Germany, in the node in Germany. So just the home SIM. In the other country, we not only measure Vodafone Germany, but we also measure the SIM, the mobile network operator, where the SIM is camping on. So let's say that you are measuring Vodafone Germany in Italy, then this one will camp in Vodafone Italy, and we measure also Vodafone Italy simultaneously with the other nodes. But let's see in details the measurements we did. So the first one is about measuring roaming setup and performance. So we basically collect all the radio metadata, where the roaming SIM is camping on in that moment, the time when it was connected, the time when it was losing the connection, for example. The second measurement we did is trace route and ping to our home measurement server in the all countries. Then we measure DNS, and in the end, Carl performs against 10 different popular web services, for example, the top 10 Alexas. Let's see the results about this roaming setup. So we were really surprised because we discovered that all the mobile network operators use home-routed roaming. It means the packet go back and forth to home before to go to the country where the server is. Let's do an example about this. So let's say that I'm Vodafone Germany, and I'm in Germany, and I wanted to access content in Germany. So this is the round trip time that I'm experiencing. Let's say that now I'm always in Germany, and I wanted to connect to UK. Of course, the round trip time is bigger because it's far away. Okay? Now I'm roaming in Germany. I'm from UK, and I want to connect to the server at home, so a server in UK. In this case, this is the round trip time, and surprisingly, the GTP tunnel is lower than the internet tunnel when you are roaming and you're going home. The worst case is when you want to connect in the country, you want to download content in the country where you are roaming. In this case, the packet has to go back and forward, so basically you lost a lot of time and you have delay penalties. For example, you are in India and you have a SIM card from Italy, and you want to access the times of India. In this case, you have to go back home, the packets will go back to Italy, and then download the content from the server that is local in India. Okay? So you have delay penalty in this case. We did the same with DNS, and we found the same thing because it's home-routed configuration. So as you can see in the figure, when you are at home, of course, you have less query times than when you are roaming. Apart from measurements, performance, apart from measuring performance and setup, we also measure VoIP, traffic differentiation. So we emulate FaceTime, Messenger, and WhatsApp traffic, and we connect from the roaming SIM and from home for measuring VoIP. And we also take in consideration content discrimination. We use Uniprobe for web connectivity tests. Content discrimination means what happens when you are you want to access content that you can access locally when you are abroad. For example, you have Netflix at home and you have some movies that you want to access roaming. So we actually test that when you are abroad, you can access this content that you usually have at home. Being the home-routed roaming, the configuration that was by default, the one for mobile network operators, we didn't find any traffic differentiation while roaming. Same for content discrimination. So for content discrimination, we match the content we find at home with the content we find when we are roaming. And we find no evidence of additional content discrimination in this case. And basically, the geo-restriction as at home. If you cannot access content at home, you cannot access while roaming, and the opposite. So, as an experience, since this is an experienced people, I will tell you more about our experience measuring this platform. Well, it was painful synchronize all the measurements because of a lot of people that, a lot of countries that are involved in this project, so 6 countries. That means that in the same time, we had to ask people to change the SIM every week, every 2 weeks, based on the measurement we have to do in that moment. So we send mails, smoke signals, whatever, to synchronize. Another thing was repurposing the Moro, readapting the Moro code that is open source. Moro is a platform that was presented last year in this same conference. Repurposing the Moro code for our platform was also difficult because we need to adapt it for our roaming purpose. And the third thing, also taking care of the Moro nodes wasn't quite simple because sometimes when you change SIMs, you have to reconfigure everything, reconfigure the ICSID and other parameters that you need to measure. So in conclusion, home routing home seemed to be the norm for mobile network operators in Europe. We talked with the mobile network operators, we tested with some of them, and they say that it's the easy way, basically, because of the billing, because of the traceability of the traffic. But of course, this brings delay penalty and potentially also bad quality of experience of a user that is traveling. We didn't find any traffic differentiation in our measurements. This is in line, and no content discrimination, and this is in line with the home-routed configuration. And for future work, we would like to go more in deep on the quality of experience of the user. So make real browser measurements, for example, page load time and whatever. So happy roaming to everybody. Thank you for listening. An important thing that I want to say is that the dataset is open. We collect these 20,000 experiments. You can connect to our roaming webpage, and you can download the data whenever you want. We have the raw data, the parsed data, all the parsers we use to parse the data. And if you have any doubts on how to do it, on how the dataset looks like, then you can just write me or Andra. We will be happy to help. And Moro roaming is an open project. You can use the platform if you have like a nice project. Then you can just write us, and we will be happy to help with using the platform. So thank you.
So our next